In my lifetime, I've deployed hundreds of applications, and whenever I visit that application in my browser, very often I see this message right over here, not secure. Now, I've seen this message many times, so I don't panic. I just follow a few steps, and a day later, bingo bango, my website becomes secure. But I never truly understood what made my website secure and why was it not secure before. Well, now I understand and I'm going to share that knowledge with you. Very simply, an insecure website uses the HTTP protocol. HTTP stands for Hypertext Transfer Protocol, and protocol just means a set of rules. Now, a secure website, what it utilizes is HTTPS. And the S, as you might imagine, stands for secure. Now, in this video, we're going to answer three basic questions. Why is HTTP not secure? Why is HTTPS secure? And how is HTTPS secure? And this is going to take quite a while. In fact, this video has about 125 slides. I'm going to go through this in excruciating detail because I really want you to understand it. So let us begin our user journey. Our user journey begins right here on the browser. Let's go ahead and visit a website. Let's visit facebook.com, for example. Okay, it looks like we're not logged in, so let's input our email and our password. And before we click login, I want to ask you a question. Our email and our password, where does that data live? On what machine? Well, currently it lives on your machine, whether it's an iMac, a MacBook Pro, or MacBook Air, or some sort of Windows machine. The email and password exists only on that machine. However, when I click log in, what I want to do is I want to transfer the data from this machine to some other machine, some Facebook server that is going to have all of the logic needed in order to validate my credentials, reach out to the database, and give me some sort of a response. Now, that communication between two different machines, that is known as networking. So let's just go through our example. So this machine right over here, what it wants to do is it wants to make a post request to the Facebook servers. Now, inside of the post request, our data is going to live. So in the request body, we're going to have our email as well as our password. Now, the process of getting this information to the server and then getting some sort of response back is quite cumbersome. So let's just go ahead and go through it. So the first thing that our machine does before it even interacts with the other machine is it compresses the JSON data. As you can see here, there's a lot of spaces here. There's a space here, there's a space here, there's a space here. You know, all this is all fine for us. It makes it nice and readable, but it just takes up more space for the machine. So what it ends up doing is it compresses it. It removes all of the different spaces. So now it's just one big line of JSON. And the next thing that it does is it converts that JSON into binary. So it converts it into a bunch of ones and zeros. So this over here, if we wanted to, we can convert this binary back into our JSON. So I actually went ahead and I pasted my binary in this binary to JSON converter, and it went ahead and it did that. So what I'm trying to say here is converting this JSON to binary, this data is saying the exact same thing, except this data over here is machine readable and is going to be used in order to transfer the data from server to server. Now, for the longest time, I never truly understood why we need binary. Why do we have to convert our beautiful human-readable code to a bunch of ones and zeros that make absolutely no sense to me, and I don't think they make any sense to you? Only once I started to understand networking did I understand the powers of binary and why we need this conversion. Now, in a nutshell, the reason is networking is not magic. Whenever we need to transfer data from one machine to another, the data doesn't just magically appear to this other machine. Instead, it needs to be transmitted and is going to be transmitted through some sort of transmission medium. So let's take a look at an example. Let's take a look at you, for instance. Let's say that you want to go from one city to another or from one country to another. How are you going to do that? Well, you need some sort of transport medium. You need a car, or you need a plane, or you need a train, or you need a bus, etc., etc. This is going to be some medium that is going to transport you or transmit you from one location to another. The same is true for data. Now, for data, the transmission medium is either going to be wired or wireless. So if it is wired, it's going to be some sort of cable that is going to transmit data from one machine to another, and the way that it does that could be different. It could be electrical signals or it could be light signals. Now, if it was wireless, it could be, for example, radio waves or infrared waves. And these are just examples. There are other different ways that wired and wireless communication mediums can transfer data. Now, what we're going to do is we're going to take a look at, for example, electrical signals. We're going to see how we can communicate data from one machine to another with electrical signals. And the process is going to be very, very, very similar for other mediums. So let's just say I want to transmit this byte of data. So a byte contains 8 bits, and a bit is either going to be a 0 or a 1. I have a cable that is connected to 2 different machines, and I want to transmit it. How are we going to do that? Well, the machine is going to do this. The machine is going to start sending electrical signals with different voltages depending on the byte of data that we have. So our machine that contains the data is going to send an electrical signal for some period of time that has a volt of 0. Now, our other machine that is getting the data is going to grab that signal and it's going to say, oh, this has 0 volts. I'm going to say that this is going to be the byte 0. And then for the next byte, the first machine is going to go ahead and send another electrical signal, but this time is going to have a voltage of 5, for example, so not 0. Then the other machine, the machine that's getting the data, I'm going to call it machine 1. Machine 1 is the one that's transmitting the data. The machine 2 is the one that's getting the data. So machine 2 is then going to go ahead and say, oh, okay, well, this electrical signal has a voltage of 5. Thus, I am going to say that this is going to be 1 byte, and so on and so on and so on. So you can see here 0, 0. These two electrical signals have 0 volts. This guy right over here has 1 volt, and so on and so on. And hopefully you can see now how networking really works. So we have these different electrical signals, and they are going to be correspondent of different bits, which are then going to be converted into bytes. And then all of these different bytes are going to come together to form our data. Okay, so now that we know that, let's just take a look at your setup. So for example, you have a machine and the machine is connected to the internet. How is it connected to the internet? Well, you probably have some sort of router. So this is what's going to end up happening whenever you want to send data from this machine to this machine over here. So the first thing is that your machine converts the data to binary. And then through wireless communication, let's just say radio waves, it's going to transmit that binary to the router. And then the router, through some sort of physical means, so whether through electrical signals or light signals, it is going to transmit that byte of data to that server over here. So that is the whole journey of your data going from your machine to the Facebook web servers. Here's the thing though, anytime that we transmit data through a physical mean, whether it's wireless or wired, it is 100% accessible to the public world. So for example, if I was sitting right next to you and I wanted to know what your email and password are, what I could do is I can just buy this thing on Amazon, which costs 17 bucks, not very expensive. And what it does is it detects radio waves and it converts it to bytes. So I can just have this roaming around in the room and I can just read all of the byte data. And once I get the byte data, I can just go ahead and convert it to human readable JSON. And look at that. Now I have your email and password. And that is exactly why HTTP is not secure. You can go on a website, you can input your credit card information, you can input your email, your password, any sensitive info. And if you're using the HTTP protocol, it is accessible to the world. I can very, very easily, if I wanted to, get access to that data. And now I have your credit card information. Now I have your password, your email. And obviously this is not great, and browsers tell you that this is not great. If you're using HTTP, your browser, whether it's Chrome, Safari, whatever, is going to straight up tell you, hey, this connection is not secure. And any time that, or most of the time that customers see this, what they end up doing is they just go ahead and leave this page because they don't really understand exactly what it means. They just look at it, oh, this is not secure. This is maybe some sort of malware. Maybe this is some sort of hacker. And they go ahead and leave. So we need to fix this. How do we fix this? Well, we don't use HTTP. We use HTTPS, and of course the S stands for secure. Now, how does HTTPS secure our information? Well, it does so with encryption. So it's really important to understand what encryption is. So I'm going to go ahead and go over it. Let's say that we have some sensitive information and what we want to do is we want to encrypt it. Now let's just go through how we can encrypt it, and I think by the end of it you'll understand exactly what encryption is. In order to encrypt this data, we first need a key. And a key very simply is a string of characters. So you can see here, this key is this string of characters, and the characters are usually just random assortments of numbers as well as letters. Now what we can do is we can utilize this key as well as some sort of encryption algorithm. So AES 256 is a very famous encryption algorithm that's going to take the data, take the key, and then form some sort of string that is kind of just scrambled up and make absolutely no sense to a normal user. If I were to give you this string, you're gonna have no idea what it means unless you have the key itself, because not only can you encrypt data with the key, you can also decrypt data with the key as well as the exact same algorithm. So you can, again, encrypt this data that is readable to you to something that is not readable to you. And if you want to go ahead and read this encrypted data, just use the exact same key as well as the exact same algorithm to decrypt it back. So this is something that is very, very important to understand. This, in a sense, is what encryption is. Now, why is that important? Well, let's go through our example here. So we have our very sensitive information. Now, instead of going ahead and converting it straight into binary, let's just say that our machine, well, encrypts it first. So now it is this form of text that makes absolutely no sense to you or me unless we have that key. and then it converts it to binary, and then it sends it to our router through some sort of wireless means. Now, if I was there snooping around trying to get this binary data, well, I can go ahead and actually get this binary data, again, relatively easily using this machine over here. But once I get it and I convert it back to its string form, this is what I see. This is going to make no sense to me, and there's no way that I can convert it to its decrypted form because I don't have access to that key. I can only do that if I had access to the encryption key. All right, so this is why encryption is very important. But just like I don't have the key, or like some sort of malicious user doesn't have the key, well, neither does the server. So let's kind of go through this entire step again. So we have our data, and we go ahead and we have our key within our computer. We encrypt it using that key, and then we, of course, convert it to binary. We send it over the network. Now our server has it. It has it as binary. It converts it back to its string form, and now it has this data over here. Now the problem is, well, how is it going to decrypt it? It doesn't have the key. You have the key. The server doesn't. So this also is kind of useless information for the server. So how can we fix this? Well, not a problem. Let's just say we send the key to the server over the network. So we have our data over here. We have our key. We encrypt it. We send this encrypted data over the network as well as the key. And now we have the encrypted data and the key within our server. And then the server can go ahead and decrypt it. Now, here's the problem. Hopefully you can understand what the problem is. The problem is this stage right over here. So in this stage right over here, we're sending our encrypted data over the network, and we're also sending our key value. Now remember, this is public. Anybody can access this. So here's me. I'm a bad actor. I'm snooping around, and now I have access to this encrypted data, and I also have access to this key. And then what am I going to do? Well, I'm going to utilize this key to decrypt this information. And there we go. Now I have your email, and now I have your password. So clearly sending the key over the network is not a good solution. So what is the solution? Well, the solution is going to be asymmetric encryption. So let's go ahead and go over this in quite a bit of detail. The encryption that I just described is known as symmetric encryption, not asymmetric encryption. Now, what is symmetric encryption? Well, symmetric encryption is when you can do both encryption as well as decryption with the exact same key. And that's exactly what we did. We utilized this key as well as some encryption algorithm to encrypt this data. And then we used the exact same key and the exact same encryption algorithm to decrypt this data. Now, this is not true for asymmetric encryption. So with asymmetric encryption, we have two different keys, a public key as well as a private key. Now we can utilize one of those keys for encryption. So let's say I utilize this public key for encryption, and now I have encrypted my data. Now let's say I want to decrypt the data back. Well, I can't use the same key that I utilized for encryption. I can only use the other key, the private key for decryption. So if I wanted to decrypt my data, I would have to use the other key. Now the same thing goes around. So if I utilized the private key for encryption, I can't use the private key for decryption. I would have to use the other key, the public key. And that is known as asymmetric encryption. You can utilize one key for either encryption or decryption, and then you would use the other key for either encryption or decryption, depending on what you did with the first key. So let's see how we can utilize asymmetric encryption in order to send data between two different machines over the network securely. So again, we have our machine over here that contains our sensitive information. It contains our email, it contains our password, and then there is this server that we want to send that data to. Now this server is going to have a public and a private key. The public key, as you might imagine, is public. It is accessible to anybody in the world. However, the private key is only accessible to the server. So only the server itself knows what the private key is. Okay, so what I want to do now is I want to send some data to this server. What is the process? Well, I'm not going to send the data outright. Firstly, I'm just going to go ahead and tell it, hey, I want to send you some data. The server is going to acknowledge that, and it's going to send me its public key. Now, if I was over here reading exactly what this value was, and I got access to this public key, who cares? It's public. I can go ahead and Google it and figure out exactly what it is. Again, it is accessible to everyone in the world. So now, well, this computer, my machine, has the public key, and it also has the key that it wants to do the symmetric encryption with. Now, of course, we can't just send this over the network because then I can get access to it. But what I can do is I can take this public key that the server returned to me and encrypt this symmetric key. So I can encrypt it now. And then what I can do is I can send that encrypted symmetric key back to the server. And if I was in the middle, I had access to it, well, I cannot decrypt it because remember, encryption is going to happen with the public key, but I cannot decrypt with this public key. I would have to decrypt with the private key. Who has access to the private key? Not me, just the server. So again, I can't do anything about this. I can still get access to this value, but I can't decrypt it. I might have access to this value over here as well as the public key, but again, I cannot decrypt with the public key. I can only decrypt with the private key, which only the server has access to. So now the server is going to have access to this encrypted symmetric key, and it also has access to the private key. Well, now it has decrypted this key, and now both the server over here, or both my machine as well as the server, have this symmetric key that they can utilize in order to transfer data securely. Now, this seems great. Is this HTTPS? Is this the whole process? Well, unfortunately, no. So this is far, far better, but it does have its security flaws. Let's try to understand exactly what that is. To do that, let's just go through this scenario again. I have some data I want to send to this server, so what do? I first tell the server, hey, I want to send you some data. Now, me being the malicious person that I am, instead of listening in, what I can do is I can intercept this request. So instead of sending it to the server, you send it to me. And over the public network, this is 100% possible. This is known as a man-in-the-middle attack. Now, I have my own public key and my own private key. And what I do is I send you my public key. So I send this machine my public key. Now, this machine thinks that this public key is from the server. So it made a request, I intercepted it, I responded with a public key. So it doesn't know that it got intercepted. This machine has no idea at this point, and it thinks that the public key is from this server. So what does it do? Well, it takes its symmetric key, encrypts it with this public key, and then tries to send it back to the server. Now, me being the malicious person that I am, I again intercept it. So now I have the encrypted symmetric key that I can, of course, decrypt with my private key. So now I have your symmetric key, You, of course, think that only the server has your symmetric key. So you're going to go ahead and start sending the sensitive information that is encrypted with this symmetric key. I can go ahead again and view this data relatively easily. But now what I can do is I can decrypt it because I have the symmetric key. So that right there is the problem. So what do we need to do? Well, now what we need to do is we need to absolutely ensure that the public key is coming from the server and not some other random person. How do we do that? This is the final boss solution. I promise you this is how HTTPS works. We do that with certificate authorities. So let's go through certificate authorities in quite a bit of detail now. So let's go through this exact same scenario, but this time with a certificate authority. So we have our machine that contains the data, we have the server that we want to send the data to, but now we also have a certificate authority. Now you might be asking, well, what in the world is a certificate authority? A certificate authority is a third-party entity that is trusted by the browser. So trusted by Chrome, trusted by Firefox, trusted by Safari, trusted by whatever browser that you are utilizing. And in order to become a certificate authority, you have to go through a pretty rigorous process. And there's not a lot of trusted certificate authorities out there. If you were to go ahead and search list of trusted certificate authorities, you're only going to get about 12. So these are third-party entities that are trusted by our browser. There's DigiCert, there's Let's Encrypt, there's CyberTrust, and then there's Komodo Group, and there's, of course, others out there. Okay, so let's just go through this exact same scenario, but this time with the certificate authority. Now, one thing I do want to note is that just like the server has a public key that is accessible to the world and a private key that is only accessible to it, so does the certificate authority. It has a public key that is accessible to the world. I can very easily Google what the public key is of a certain certificate authority is, but I don't know what its private key is. The private key is very specific only to the certificate authority. Only the certificate authority knows the value of this private key. All right, so now that we understand that, I'm going to quickly just apologize in advance. There's going to be a lot of asymmetric encryption here. There's going to be quite a bit of keys. I'm going to try to go through this as slow as possible, but if you do get confused, please pause the video, go back, and try to kind of understand what's going on here. I'll try to do my best. Okay, so we have my data over here that I want to send to the server. What do? I do the exact same thing. I'm like, hey, I want to send you some data. Now, instead of the server sending me back the public key, this is what the server does. The server sends the public key to the certificate authority. And what the certificate authority is going to do is create a certificate. And a certificate very simply is a text file that contains information. And it's grouped into 3 different parts. So let's kind of go through that in a little bit more detail. So the first part is going to contain basic information about who we're issuing the certificate to. So we're going to issue eventually the certificate to this server, and this server is facebook.com. Remember, this is the facebook.com server. So it's going to contain information about, the domain, as well as maybe where this server lives. Maybe it lives in Berlin, for example, as well as some other information that I just decided not to add in here. And then it's also going to contain information about who is issuing the certificate authority itself. So let's just say that the certificate authority that we utilize is DigiCert. Well, over here it's going to contain information about DigiCert and maybe where the server lives, like Canada, for example, as well as, again, some other information that I just decided to omit. All right, so that is the first part of this certificate. The second part of this certificate is the server public key. So what is the server public key? Well, remember, this is the server over here, and it sent the certificate authority its public key. So what it's going to do is just grab that public key and just put it inside of the certificate outright. Okay, so that's good. Now, this is the third part right over here, and this is where things get really, really important. What the certificate authority is going to do now is take the server public key, and it's going to encrypt it with the certificate authority private key. And now what we have is an encrypted server public key. Okay, so again, let's just go through this again. So we have the public key and we have the private key of the certificate authority. And again, I can encrypt with the public key if I want to, or I can encrypt with the private key. But if I decide to encrypt with the private key, only the public key can decrypt it. All right, so I'm going to go ahead and I'm going to encrypt this server public key with this private key, and now I have this encrypted server public key, and that's going to contain all of the information inside of the certificate. Now, this portion right here is known as a signature. This is saying that, hey, this trusted certificate authority just signed this certificate with its public key, or with this private key right over here. Now, one thing I want to quickly just stress here is that we're not sending back the private key itself. What we're doing is we're just sending back the encrypted server public key that is encrypted with this private key of the certificate authority. Okay, so with that being said, what's going to happen now? Well, what's going to happen is the certificate authority is going to send back this certificate that contains this information. And then what's going to happen is the server is going to send this certificate to our machine. Okay, so it's going to send it to our machine. Now, this is what our machine is going to do in order to 100% validate that the server public key is actually coming from our server and not some malicious user. It's going to take this certificate, so now it has this information, and what it's going to do is it's going to take a look at who issued this certificate. So in this case, it is DigiCert. So it's going to say, hey, DigiCert, I want your public key, give it to me. So we're going to go ahead and take this public key from DigiCert, and then this is what we're going to do. So now we have the public key of DigiCert. We have the server public key, so which is this key right, or let's go back, which is this key right over here. So we have that, and we also have the encrypted server public key that was encrypted by the private key of the certificate authority. Again, I want to stress that these two, the private key is not sent within the certificate itself. Only the encrypted server public key is sent. I just kind of wanted to just show you how it was created. So now our machine has all this information. So what we can do now, because we have the certificate authority public key and we have the encrypted server public key, what we can do is we can decrypt this. We can decrypt this signature. So I'm going to go ahead and decrypt this signature, and that's going to give us the decrypted server public key. And now, in order to 100% validate that the server public key was indeed coming from Facebook.com, what I would do is very simply check, hey, does the decrypted server public key equal to the server public key over here? If that is the case, then I know that this is indeed the server public key. And then what I can do is I can kind of go through that exact same process that I highlighted before in order to form that symmetric key. And then we can form that encrypted, a secure session between my machine as well as the server. The last thing that I want to talk about is chain of trust. So like I said in a previous slide, there's only a few listed trusted certificate authorities out there. Now, hopefully this goes without saying, but the private keys of these certificate authorities 100% have to be secured. If they are compromised, that is not good news. Why is that not good news? Well, there are billion-dollar companies out there that rely on the certificate authorities. So for example, HelloFresh, Y Combinator, as well as Discord, they're all billion-dollar companies that rely on the Cyber Trust Certificate Authority in order to form secure connections between the user's machine as well as their servers. Now, of course, the certificate authority has a public key as well as a private key. Now, if this private key ever got compromised, just think about how bad that's going to be for HelloFresh, Y Combinator, and Discord, for example. Let's just talk about HelloFresh. Let's just use that as an example. So HelloFresh, I'm not sure if you're familiar with it. It's actually the company that I work for. What they do is they deliver food to you. So they're going to need information about, your phone number. They're going to need your email. They're going to need your address. They're going to need your credit card information because, of course, they're going to charge you. Now, if this private key was compromised and some user made a request to HelloFresh, maybe purchasing some sort of subscription and passing in their credit card information or passing in their email or whatever sensitive information there is, well, now a malicious user can intercept that data and decrypt it because they have the private key. That is not good news. So this is what they do to combat this. We want the private key to be as far from the internet as possible. So what do we do instead? Well, we have an intermediate certificate authority. Now, Cloudflare is an intermediate certificate authority for cyber trust. So instead of HelloFresh reaching out to the certificate authority itself, it reaches out to the intermediate certificate authority, and it goes through the exact same process that we have just outlined. And then the intermediate certificate authority reaches out to this cyber trust, which is the actual trusted certificate authority, and it goes through the exact same process. So what we end up with is a chain of certificates. The chain of certificates are going to look something like this. So we're going to have our server certificate, and the owner information, for example, is going to be hellofresh.com, Berlin, and whenever. And what we want to do is we want to validate this signature. So what are we going to do? Well, what we're going to do is we're going to look at the issuer information, and the issuer information is not going to be the trusted certificate authority. Instead, it's going to be the intermediate certificate authority. So this is going to be Cloudflare. So what we're going to do is we're going to ask for Cloudflare's public key, and we're going to access it. And then using the public key, we're going to validate the signature. So we're going to go through that exact same process that we have gone through. But now what we need to do is we need to actually validate, hey, is this intermediate certificate authority, is it even trusted? So now we have to validate the signature of the intermediate certificate authority. So we take a look at the issuer right over here, and the issuer just so happens to be Cyber Trust, which is indeed a trusted certificate authority. We take its public key, we do this decryption process, and we validate, okay, so this is indeed valid. But now the absolute last thing we need to do is we need to validate the certificate authority that is trusted itself. And this is known as the root certificate. So we have to validate this signature over here. Now what's unique about this signature is that it is self-signed. So if you were to take a look over here, this signature is signed by this intermediate certificate authority using this private key. And this signature over here is signed by this private key. Whereas this signature, because this is a trusted certificate authority, well, this is going to be self-signed, signed by its own private key. And if you were to actually take a look at the issuer information as well as the owner information, they're going to be exactly the same, which proves that it is indeed self-signed. Whereas over here, of course, it's going to be different. In this case, the owner information is going to be HelloFresh. The issuer is going to be Cloudflare. Over here, the owner is going to be Cloudflare. The issuer is going to be Cyber Trust. But in this case, the owner and the issuer, they're both cyber trust. So we have a self-signed certificate. But nonetheless, this is a certificate authority that we 100% trust. We're just going to take the public key and we're going to go ahead and validate this signature. And only once we validate all three of these certificates are we going to get a secure connection. So that right there is HTTPS, S standing for secure, in a nutshell. Well, it wasn't really a nutshell. This was a relatively long video, but hopefully you appreciated it. Now, the last thing that I want to do is I just kind of want to explore these certificates in the browser. So let's just go ahead and quickly do that. Here I am on the HelloFresh website, and can we just take a quick minute to appreciate how good this looks? Okay, enough of the advertisements. I do work for HelloFresh as a software engineer, so they do pay me, but they're not paying me to advertise their video. So I'm just not sure if it's sponsored or not, but I'll just keep that disclaimer out there. Nonetheless, enough of the advertisements. What I want to do is I want to go ahead and copy the URL. And I'm just going to paste it in Google. And you can see that HelloFresh is using HTTPS. So it has a secure connection. And we can actually see that this connection is secure because right beside the domain, might be a little bit small for you guys. I can't unfortunately zoom in over here, but there is this lock icon. And if I were to click on it, you can see here it says connection is secure. Now what we can do is we can actually get more information about this secure connection. I can go ahead over here and click on this, and it says here certificate is valid. I'm going to try to zoom in. No, it doesn't work, unfortunately. So it says here certificate is valid. So now I can go ahead and click on that, and it's going to give me more information about the certificate itself. So this might be too small for you, but I highly suggest try this out in your own browser. Over here you can see issued to. So this is issued to HelloFresh.com. The organization that's actually doing the issuing is Cloudflare, like I showed you. It was issued on Friday, April 7th, and then over here, each certificate always has an expiration date. So this one is going to expire in April 7th of 2024. Okay. Now, if I were to go click on details, now we can actually see that chain of trust. So we have over here HelloFresh.com. That is going to be the server certificate. And then over here, this is going to be the intermediate certificate. And then over here, we have the root certificate. And we can get a bunch of information about this. So over here, again, we can get the subject public key info. So if you wanted the public key, that right there is the public key. And that is the public key for the HelloFresh certificate. If we wanted the algorithm for their public key, we can get that information. If we wanted to figure out who is issuing it, well, Cloudflare is the one that's issuing it. And now if I were to go over here and click on Cloudflare, I can get the exact same information. So who's issuing the certificate for Cloudflare? Well, now Baltimore Cyber Trust root, that is the issuer. I can also grab its public key right over here. This is the public key. Again, the public key is accessible to anybody. And then lastly, I can go to the root certificate authority. I want you to take a guess. Who do you think the issuer is going to be? Well, the issuer is going to be very simply Baltimore Cyber Trust, because this is going to be a self-signed certificate. So we can always see this information in any secure website that we want. Okay, so I think that pretty much concludes everything that you need to know about HTTPS and forming secure connections. This did take me quite a while to not only film, but to understand. So hopefully you do appreciate it. Give this video a like or a dislike. If you absolutely hated my explanation, I don't mind. Just go ahead and utilize this info.